Hello, you marvelous fifth graders. I hope you had fun with the last few weeks of experiments, doing all that shaking and measuring. I tell you, science can be so much fun and so interesting. I hope you had fun figuring out what the mystery substance was. It was citric acid, right? So I want to do just a quick little review of some of the main ideas that we've been talking about. A mixture is a combination of materials. Some mixtures are really easy to separate. You can use a magnet to separate paper clips from rocks. You can use a screen to separate sand from pebbles. That's a mixture. A solution is a special kind of mixture where one thing dissolves inside another. There is a solvent, which is the liquid that does the dissolving, and the solute, the thing that actually dissolves. And then there is saturation. When the solvent can no longer dissolve any of the solute, you have reached saturation. Now, a property of a material is how soluble it is. There is different amounts of solubility, and we saw that in our experiment. The solubility of table salt is much lower than the solubility of citric acid. So we're going to stop dissolving things right now. And when we talk about dissolving things or changing things from a solid to a liquid or from a liquid to a gas, that is just a change of state of matter, right? There's three types of matter: solid, liquid, and gas. And you can add heat or take away heat, or you can dissolve things and change the state of matter. That is a physical change. But if we put that water out, that salty water out, the water will evaporate and I'll get the salt back. I didn't change the salt except change it from a solid to a liquid. Now we're going to start focusing on chemical changes. I have some of the same solids that we looked at in our last experiment when we were talking about whether things dissolve. So I want to just see what happens when we put those same materials with 50 milliliters of water. I'm going to use calcium chloride, which is a new material. So I've got 1 spoon of calcium chloride. I'm going to add 50 milliliters of water. And I made a solution out of calcium chloride and water. Now I'm going to try to dissolve some baking soda in water. Here's 1 spoon of baking soda. And I'm going to stir it up. There appears to be still some more baking soda at the bottom. So it appears that maybe baking soda is not as soluble as the calcium chloride. I'm going to add another 50 milliliters of water and see if I can get all the baking soda to dissolve. So the baking soda will dissolve as long as it has more water. So it has a lower solubility than calcium chloride. And now I'm going to add 1 spoon of citric acid and 50 milliliters of water. And all of the citric acid dissolved in 50 milliliters of water. So I have 3 different mixtures, solutions, and those materials all dissolved in water. This one is a little milky, but there's no material at the bottom. It just made the water a little milkier, a little bit more opaque. But all of these materials will dissolve in water. Now what I would like you to do is to put these 2 different materials together. What happens when we mix the solids and then add water? Can you please get this page? It says 2 substance mixtures, and glue this into your science notebook. Okay, I have it in my science notebook, and now I want to see what we're going to do. We're going to get 3 cups. In cup 1, we're going to add calcium chloride and baking soda. That will be a mixture. Here is cup number 1. It is a mixture of calcium chloride and baking soda. Cup number 2, add 1 spoon of calcium chloride and 1 spoon of citric acid. Here is cup number 2. Cup number 3, add 1 spoon of baking soda and 1 spoon of citric acid. Here's cup number 3. Before we add the water, can you please add this on the next page? Observations. Cup 1, cup 2, cup 3. Then, when you add the water, please spend a few minutes before you go on to the next cup writing down all the observations that you notice. What happened in cup number 1? Did you see something happen? Did you hear something happen? Did you feel something happen? Make sure you make those notes before you go on to cup number 2 and before you go on to cup number 3. Now that we have our 3 dried mixtures, I would like us to add 50 milliliters of water to each cup. Please do it slowly so that you can observe each one. This is cup number 1. Make sure you touch the cup so you can observe all the properties of the chemical reaction. Here's cup number 2. Cup number 3. Make sure to touch the cup so you can feel what's happening to it. Now let's answer this question at the bottom. Number 1, which substances reacted to form a gas? So how do we know that there was a gas? Well, we saw bubbles. Did you see bubbles in any of the cups? And if so, which ones? Then, question number 2, which substances reacted to form a precipitate? A precipitate is when there's a chemical reaction and something falls out of the liquid. So, there would be a solid or some type of material sitting at the bottom of the container. Does cup number 3 have a precipitate? I see bubbles, but I don't see any solid material or any type of material at the bottom. Does cup number 2 have a precipitate? No, I don't see anything at the bottom. Cup number 1. Do you see those 2 layers? There is a layer of liquid on top, and at the bottom there seems to be a white milky substance that has fallen to the bottom. That white milky substance is the precipitate. So which cup has a precipitate? Number 1. We had 3 cups. Cup number 1, that has something at the bottom. And that thing on the bottom is the precipitate. Cup number 2, we didn't see any bubbles. This might just be a solution. This might be a physical change and not a chemical change. And cup number 3, baking soda and citric acid. We saw lots of bubbles and the cup got very cold. That is an indication of a chemical change. I'm a little interested in this precipitate. I'm going to ask you guys to save the precipitate. Don't pour out this cup. I'm going to filter it out and allow the water to evaporate. And I want us to do some additional tests on it next week. See you next week, guys.